All right. Greetings, everyone. I'm Jae Yun Lee of PopcornSAR. Today, I'm going to introduce how AIs can be applied to resolve the pain points of AutoSAR development and increase engineering productivity. Well, in part one, I'm going to give you a little bit of background of the paradigm shift happening in the industry and identify the engineering bottlenecks that tier ones are facing. These are the agendas. I'll just skip this part. So, paradigm shift. Back in the days, the value of vehicles were defined by the quality of hardware. How fast is it? How sturdy is it? Can it go far with less fuel? And after that, the concept of SDV emerged. The value of vehicle began to be defined by software. So things like decoupling, architecture standards, and over-the-air updates became important. But in the future, vehicles will be defined by AIs. AI is evolving from an add-on feature to the central nervous system that controls all domains. But in order to reach this point, company-wide AX, in other words, making your employees utilize AI is crucial. So, what exactly is an AI divi? Well, this is quite interesting because the terminology is used differently among Western industries and Chinese industries. The Western sees AI divi as a product. AI will be installed in the vehicle and control all domains like ADAS, infotainment, and mechanical features. AI learns within the vehicle and will be customized to the driver's preferences. OTA, of course, will be about updating the in-vehicle AI model. On the other hand, China sees AIDV as a process. They focus more on utilizing AIs to accelerate the development process. AIs now generates codes, then the specifications, and designs the architecture. They collect data not only from actual driving done by customers, but also from the entire R&D designing and manufacturing processes. This is why Chinese OEMs and Tier 1s are so fast in launching new vehicles. Statistics says that Chinese OEMs launch new model in 1 to 2 years, while Western OEMs like Tesla takes 4 to 5 years. Let's dig down a little bit more how China adopts AI into their R&D toolchain. Huawei recently announced their code store, which automatically analyzes docs, this coding, and defects tracking through 6 AI agents. There are also automotive specific LLMs like Car LLM and Llama Review that are fine-tuned for automotive software code review. Then there are AIs that does simulations. It is said that 65% of the test protocols in China are done by simulation, and 75 of them are AI automated. This makes time to market in China reduced to 11 months. And finally, Chinese OEMs like Geely, Xiaomi, NIO, and so on are applying their AI methodologies used in R&D into manufacturing. So as you can see on the image on the right, all the OEMs that got high scores in the both steps and widths are all Chinese OEMs. As the industry changed rapidly, new problems started to emerge, especially to Tier 1 suppliers. Well, back in the days, things were simple. Tier 1s handed over bundles of hardware and software combined as a black box. They only had to specialize in few talents like mechanical and electronic engineering, and the development environment was not that diverse. But now, hardware and software have to be decoupled and be handed over separately as a white box. More talents are also needed, like cloud and AI, and the tool chains and platforms that OEMs requires to use are more diverse. That is why Tier 1's margins are falling to a danger zone. More skills are required, and labor costs are rising. But they can no longer earn the integrated margins from black box delivery that they used to do. Let's narrow down the labor cost. to AutoSAR developers specifically? Well, we all know that AutoSAR is hard to master, so the salary of experts is very high. In the US, they make about $150,000 a year, which means that wasting their working hours lead to significant loss for the company. But the problem is, they are actually wasting their time. According to a recent survey, only 16% of the working hours are spent on new feature design and coding, and the rest is spent on code maintenance and specification and writing test cases and so on. Then, on another report, it is said that only 52 minutes a day is spent on writing code. So companies are bearing dual opportunity costs of labor loss and new vehicle delays. Then another problem that our industry is facing is the complexity of AutoSAR itself. When AutoSAR first emerged back in 2003, it was aimed to eliminate hardware dependency and maximize software reuse. But as more and more features started to be added on by different stakeholders, the runtime environment got heavier, leading to extreme configuration and CPU overload. Well, our engineers first have to read through 30,000 pages of AutoSAR specification and over 80 base software modules, configure thousands of parameters, and have to track every year when AutoSAR releases a new version. We actually had a meeting with the Great Wall Motors in April, and they told us that it took them 3 weeks on base software configuration, so they were looking for solutions to shorten the process. Apart from GWM, many of our partners like TFO US and SDVS told us that a lot of Western OEMs are trying to replace AutoSAR within their in-house middleware. Tesla, Rivian, Volvo, as you already know, are building their own software stack and architecture. So, because of this fragmented ecosystem, Tier 1s have to switch through development tools and customize their outputs per OEM requirements, depending on whether the OEM uses AutoSAR or not. But these OEM requirements are not easy to handle. They come in as PDF with watermarks, Excels with macro tangles, Word docs, low resolution JPG, all jumbled as an unstructured collection of files. Plus, even the terminologies used are different within each OEMs. Then, when we look into the actual contents and requirements, we found out that a lot of them are unnecessary information. So, only 30% of the contents are functional requirements directly tied to the software development, like camera detection and response triggering. And the remaining 70% are non functional requirements, like environment constraints, regulations, and history references. So our engineers must filter those noises manually. And finally, we have compliance. Early this year, the Hyundai Motors announced to the supply chains that they will not make contracts with suppliers that fall below ASPICE Level 2. Like this case, standards like ASPICE, ISO 26262, and Measure C are considered as entrance conditions to the market. Why? Mainly because of OTA. If customers report some errors but we can't track what was the cause, the OTA itself becomes a safety risk. But in order to achieve a spice, it costs a lot of time and money. In case of us, it cost about 2 years and about $30,000 to achieve CO2. But however, many tier ones that are good at hardware manufacturing but lack at software development cannot handle the massive software compliance workload So they eventually outsource it to multiple tier 2 software vendors. This is where all the fatal problems occur. Each vendors use different coding style, compliance, and tools like Jira, Polarian, and Redmine. So the architecture and traceability shatters upon integration, making it hard to identify the root cause ID when errors occur. Plus, security gets vulnerable due to multiple external vendors accessing the system. Sorry. As the traceability chain collapses, Ace by Sudden fails, and those tier ones eventually fail to get contracts in the market. Hmm. So, so, how do we solve this? The answer is, of course, AI. Sorry. Well, for the past 10 years, we have been accumulating expertise in AutoSAR, receiving feedback from our customers, and last year, Cloud released the concept of skill and agent, and we immediately recognized that this could be a game changer in AutoSAR development and compliance. So we made it. The first is our compliance automation solution called Parvis. It basically creates documents and codes that comply with ASPICE, ISO 26262, and MISR C. On the large end, it consists of three layers: the spec, the coder, and the verify on the very top. And then it has several sub-agents, skills tools, and various methodologies on the bottom that automatically creates ASPICE outputs. Well, to dig down a little more, well, the spec is where all the requirements analysis, structuring, and documentation happens. So when we first receive the requirements files from our clients, we classify them into data that AI can process and data that AI should never touch. Then we build role-based deterministic tools to process the non-AI data exactly as told. And then we also build ontology on customers' knowledge by utilizing methodologies like LLM Wiki or RAG-based database for reference. Then we leave the rest to AI. These initial non-AI steps are very important to prevent hallucination. And then, oh, sorry. The coder is mainly focused on code refactoring. It automatically applies MrC rules along with client's internal coding rules. And it also generates the comment-based API documentation. And finally, we have the verify. Well, the test cases and generation happens. This also has an AI and non-AI separated sublayers below, but I will not go into deeply. I just have to say that bidirectional traceability matrix is generated throughout the entire pipeline, so you will be able to track errors more easily. This is the overall pipeline that I explained so far. Each stage of the V model took about 5 to 10 hours, well, depending on the size of the input. But I must mention one crucial concept. Gate review done by human experts, or in other words, human in the loop, must be done on each output. Well, this is to prevent hallucination and to enhance the outcome by giving feedback to the pipeline again. And reverse engineering is, of course, important. So we made it possible. We can now analyze legacy codes and then extract requirements from the code bottom up. So tier ones that would like to transit from outsourcing to in-house development can extract docs like SRS, SAD, STD from codes made by other vendors. These are the actual outcomes, screenshots of the software architecture design document and software detail design document made by Parvis. For this project, we input classic AutoSAR, XML source, and then source codes and CAN-DBC files. The next is PIO. This is our AI-driven AutoSAR CP and AP authoring tool. Well, it's an AI tool that deeply understands AutoSAR specifications, so you just need to input files for reference and tell it to design what you want to make in natural language. We currently support Claude, Gemini, Codex, and local models like GLM or Quen for Chinese clients also. And the target version is R25-11. We made it to provide Q&As and recommendations of the design and also reviews the design. So beginners will also be able to use it quite easily. These are the specific editors included. Both adaptive and classic platform can be designed in a single tool, along with system design, data type, port, signal, and ECU configuration, and so on. We also added features, We also added features for external XML file import and export. So as you can see, if you are using other tool vendors, tool like Vectors or eTasks, and want to use Fire only for reviewing the files you created, it's also okay. We completely support the importing. And then this is the actual outcome, of the little bit low resolution, but I just inputted the publicly opened Hyundai's EV architecture and then told it to create the IVC and VFB function. And if you want a more detailed and more higher quality outcome, you will have to input more detailed prompts and reference files. And then finally is the Para. It is a Rust-based platform, also adaptive platform. And like Pio, the target version is R25-11. So why did we use Rust? Well, majority of vehicle software defects originates from memory errors. In our former C++-based platform, we used to fix this through runtime test and static analysis, but this couldn't be the fundamental solution. And with the new Rust platform, memory errors such as use after free and buffer overflow are prevented at the compiling stage. And data race is also prevented, even in multi-core HPC environments. So recall risk, emergency updates, and verification cost can all be reduced. And then, these are the actual functional clusters provided. They are all in-house developed and complies with the AutoSAR AP standards. And the API itself is standard C++ R interface, so you can use your existing application and development assets without changing anything. Well, this is pretty much the end, so I will give you a final overview of the AI pipeline. So generate docs, codes, and test cases with Parvis, design it with Pio, then executes code and implement them in Para and PRT. That's pretty much the end.
Thank you. And sorry for the clicker. We probably have to replace it now. Sorry. But let's see. We still have time. So are there any questions?
Yeah, Marco Wirth from Vector Informatik. You mentioned human in the loop. So when you implement such a highly automated agentic workflow, how do you keep the human in the loop, and how do you make it possible that the text output which is generated by these agents, how to make it feasible that the human does not become the bottleneck?
Well, for the human in the loop, we do provide a stop point for each V model stage to actually give the time for the humans to review. But as you mentioned, human review itself can be a bottleneck in the process. So we first make it review it through another AI model. So if we used Claude for the generation, then we use like codecs for reviewing the outputs made by Claude first as a initial reviews, human in the loop stage, and then we give the output and review outputs to actual human experts for them to quickly review rather.
Any more questions? There's another question. Here, Mona.
I wanted to ask a question about basic software generation with your tools. Whether I use maybe CP AutoSAR configure to generate code, or AI directly generate code with AI channel generated by itself. Do you understand?
Sorry, can you repeat the
Uh,
question again?
I ask the way to generate basic software code with AI. In your tools, whether AI generate code directly, or AI use maybe use like Vector configure some tools to generate. It has maybe fixed way.
Well, the code generating function itself is not inside the PIL for the AI for the AutoSAR XML generation, but it is in the Para. The code generating function is in the platform stack that we provide. So once you toss the XML and manifest files generated through the PIL, the AI, it will the code generator in the Para will see the files as a reference and generates the codes in accordance to the XML, and then you can run the codes in the platform. That's the whole process.
No, I think maybe let me help in what he was asking. I think you correct me if I misunderstood you, but I think what you asked was, does your tool generate the code or just configure the code? I think that was the question. Yeah. Okay. So is it basically you can, I mean, to the extreme, you have some tool to say, okay, I need this kind of code, and then it actually generates it from an AI, or you just configure and you have like pieces which are generating it. Yeah.
Well, to be honest, I'm a salesperson, so I cannot exactly tell you the specific details, but there are the code generating functions. Not all of the specific codes, but the code generation function for the Parvis, there is a code generating function. And then for the configuration, the PyO does the configuration through AI, but code generate function is in Power, and that is not AI. So yeah.
Maybe where I can help also with your answer, I would recommend you maybe meet at the booth.
Please come to a booth.
Yes.
Our engineers are over there, so you can ask directly to solve your questions.
I have a last question on Rust. How many of your projects, like in Korea or wherever your customers are already Rust based versus like C, C++ based? Is there a percentage like?
It's quite hard to ask, but Rust-based. Mm, well, the Rust-based platform is just launched on April. So
April?
yes,
Okay.
it's only been 2 months, so
Okay.
not sure of the market demand of the Rust in the current market status. So
But obviously you did it because your customers want it.
yes,
So
they
do
will.
you see is it a large trend or is it more an exception? How big you see the Rust
No, it's not
demand?
it's not an exception because
It's a lot.
yeah, there are a lot because yeah, they all requested for the Rust. So the original R25 at 24-11, every previous version were all C++, but our customers were not only our customers, the Korean trend and globally, Volvo is also applying the Rust, and so yeah, we developed the functional clusters in Rust language.
And so then who of your customers is using AUTOSAR AP?
Well, the AP stack goes into the KGM. It's going to be on production level. It will be come out on 27, I think 28. Yes, so it's going to be out in mass production with our AP stacks. So that's one. And
27, 28 at Hyundai Kia Motors.
yes, KGM. It's the call.
Okay. Good. Then thank you very much.